Welcome back dear students. We have started with the chapter surface chemistry. In our last video, we have discussed regarding the terminologies involved in the surface chemistry. We have seen the definition for the adsorption. We have seen how does adsorption differ each other and what are the main criteria for the adsorption. We have seen adsorbent, adsorbate molecules. How does it is considered as surface phenomenon with the various examples. We have concluded the last session very well. In today's class, we understand some of the thermodynamic part which is involved in surface chemistry of adsorption process. Adsorption process mainly going to follow thermodynamic like notations. Let us start with very first one, that adsorption is kind of we can say that it is exothermic. How? Whenever we consider any surface, this is the surface on which adsorption is going to take place. It is considered as an adsorbent on which process of adsorption takes place, and adsorbate molecules are coming and they are attaching. How much surface area is possible, so much molecules are going to come and they will attach on the surface. Okay, whenever the amount of molecules they will come and attach on the surface, what happens during attachment? Energy is released. Energy is released away from the surface. As energy is released, we can say that it is exothermic reaction. If the energy is needed, it is endothermic. If the energy, when we have surface, molecules are coming and they are attaching to the surface. While attaching to the surface, certain amount of energy is going to be released. That is the reason why adsorption process is going to be referred as exothermic reaction. So for exothermic reaction, always remember delta H value, that is enthalpy, is always negative. I will show with an example here. I have a surface here. Here some of the molecules are coming and they are adhering on the surface. While adhering to the surface, what happens? Amount of energy is released. Amount of energy is released. As certain amount of energy is released, we can say that it is exothermic in nature. So exothermic nature is going to be represented that delta H value is going to be negative. Okay, we generally follow Gibbs free energy. Before to that one, let us first understand what will be the values for the enthalpy and entropy. Finally, we can consider Gibbs free energy equation here for a spontaneous reaction. First you do complete this one. I will tell you how does entropy change takes place. Then we will move to the further. Take this. Now let us understand how does entropy value is going to change with respect to the adsorption process. We have seen enthalpy process. Previous to this one we have seen enthalpy. In enthalpy what happens? Delta H value is going to be negative because on the surface, whenever molecules will come and attach, there is a certain amount of energy is going to be released. So it is considered as exothermic reaction. In exothermic reaction, always delta H value will be negative. Now let us understand regarding the entropy. Entropy is kind of disorderness. Disorderness in the system is referred as entropy. So how does entropy values can be detected? Entropy values are going to be concerned with that of the adsorption. Let us understand that one. Now see here. We consider, but some of the gaseous molecules are wandering here and there in a unsymmetrically. That is, there is no any kind of arrangement or anything, that nothing is there. Like in a system, they are wandering here and there. Now, we want these gases going to be adsorbed on particular surface. How they are going to be adsorbed on the surface? Just by increasing the pressure. If you increase the pressure, adsorption process is going to take place. The molecules, gas molecules who were wandering here and there, now they are coming closer to each other and they are adhering onto the surface of a adsorbate. When they are adhering to the surface, I write here, this is the surface on which adsorption takes place. So these are random gaseous molecules, wandering here and there. Now they are going to come on the surface. They are going to try to adhere on the surface. Now what happens? Molecules previously wandering here and there, they are coming to close to each other. Then they are adhering to the surface. While adhering the surface, also what happens? Amount of energy is released. Gaseous molecules, while adsorption entropy value also is going to be negative. Energy is going to be released. I have written here, when they start coming to surface, all gaseous molecules again loses energy. That is the reason why randomness. Previously they were very much random, here and there they were wandering. Now what happens? Due to increase in the pressure, they are coming close to the surface. When they are coming very close to the surface, what happens? Randomness is decreased. Entropy is going to be decreased. They are becoming systematically arranging on the surface. So delta S value again becomes negative. Remember, for adsorption process to be spontaneous according to Gibbs expression we consider. Next I will do that one. For the adsorption process to be spontaneous means adsorption process ತನ್ನಷ್ಟಕ್ಕೆ ತಾನೇ ಆಗಬೇಕು, ಯಾವುದೇ ರೀತಿ ಪ್ರೆಷರ್ ಇಲ್ಲಾರ್ದ ಅಂದ್ರೆ ಡೆಲ್ಟಾ ಎಚ್ ವ್ಯಾಲ್ಯೂ ಅಂದ್ರೆ ಸರ್ಫೇಸ್ ಮೇಲೆ ಯಾವ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಬಂದು ಅಟ್ಯಾಚ್ ಆಗತ್ತವಲ್ಲ ಆ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಎನರ್ಜಿನ ರಿಲೀಸ್ ಮಾಡಬೇಕು. ಜೊತೆಗೆ randomness, that is entropy value, if you consider, these randomly moving molecules must also be arranged systematically on the surface. For that arrangement also energy must be released. ಯಾವಾಗ ಎನರ್ಜಿ ರಿಲೀಸ್ ಆಗ್ತೈತಲ್ಲ ನಾವು ಅದಕ್ಕೆ ಏನಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ? ಎಂಟ್ರಾಪಿ. ಎಂಟ್ರಾಪಿ ವ್ಯಾಲ್ಯೂ ಕೂಡ ಏನಿರಬೇಕು? ನೆಗೆಟಿವ್ ಇರಬೇಕು. ಎಂಥಾಲ್ಪಿ ವ್ಯಾಲ್ಯೂ ಕೂಡ ನೆಗೆಟಿವ್ ಇರಬೇಕು. So these two let us substitute in a Gibbs expression and then we will see how does Gibbs free energy expression can be written for the adsorption process. Please do copy this. We'll move to that. Now let us understand regarding the thermodynamics with respect to Gibbs free energy. ಇಲ್ಲಿ ನೋಡ್ರಿ ನಾ ಏನು ಹೇಳತ್ತೀನಿ ಕರೆಕ್ಟಾಗಿ ನೀಟಾಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋರಿ, ಬಿಕಾಸ್ ಈ ಪೋರ್ಷನ್ ಮೇಲೆ ಗ್ಯಾರಂಟಿ ಕ್ವೆಶನ್ಸ್ ಬಂದೇ ಬರ್ತಾವೆ. ಬೋರ್ಡ್ ಎಕ್ಸಾಮಿಗೆ 100% 2 to 3 marks ಕ್ವೆಶನ್ಸ್ ಈ ಪೋರ್ಷನ್ ಮೇಲೆ ಬಂದೇ ಬರ್ತಾವೆ. ಟ್ರೈ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಥಿಂಗ್ಸ್ ವೆರಿ ಕ್ಲಿಯರ್ಲಿ. ಸಿ ಹಿಯರ್, Gibbs free energy expression for any spontaneous reaction. ಯಾವುದೇ ರಿಯಾಕ್ಷನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ತನ್ನಷ್ಟಕ್ಕೆ ತಾನು ನಡೀತಾ ಇರಬೇಕದು. Say for example, I have a bucket of water, hot water. I is supposed to get bath, so I had kept some of the bucket of water. Bucket ಒಳಗೆ ಏನು ಮಾಡಿದೆ? ನೀರು ಬಿಟ್ಟಿದ್ದೆ, ಬಿಸಿನೀರು ಬಿಟ್ಟಿದ್ದೆ. ಅನ್ಫಾರ್ಚುನೇಟ್ಲಿ ಯಾರೋ ಮನೆಗೆ ಬಂದರೆ, ಗೆಸ್ಟ್ ಬಂದರೆ ನಾ ಏನು ಮಾಡಿದೆ? ಅವ್ರ ಜೊತೆ ಮಾತಾಡ್ಕೊಂತ ಕುಂತೆ. ಅವಾಗ ಏನಾಗ್ತೈತಿ? ರೂಮ್ ಟೆಂಪ್ರೇಚರ್ಗೆ ಬಿಸಿನೀರಿಗೆ ನೀವು ಓಪನ್ ಆಗಿ ಇಟ್ಟರೆ ಏನಾಗ್ತೈತಿ? ಬಿಸಿನೀರಿಂದ ಆವಿ ಎಲ್ಲ ಹೋಗಿ ಹೋಗಿ ಬಿಸಿನೀರು ಏನಾಗ್ತೈತಿ? ತಣ್ಣಗಾಗ್ತೈತಿ. ಆಗ್ತದೋ ಇಲ್ಲೋ? ಸೊ ದ್ಯಾಟ್ ಪ್ರೊಸೆಸ್, ಆ ಬಿಸಿನೀರು ರೂಮ್ ಟೆಂಪ್ರೇಚರ್ನ ನಾವು ಇಟ್ಟರೆ ತಣ್ಣಗಾಗ್ಲಿಕ್ಕೆ ನಾವು ಯಾವುದೋ ಒಂದು ಎನರ್ಜಿನ ಕೊಡಬೇಕಾಗಿಲ್ಲ, ತನ್ನಷ್ಟಕ್ಕೆ ತಾನೇ ಆಗ್ತೈತಿ. ಹೌದಾ? ಸೇ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೆಕ್ಸ್ಟ್ ನಿಮಗೆ ಬಿಸಿ ಬಿಸಿ ತಾಟ್ನಾಗ ಊಟ ಮಾಡಲಿ ಅಂತ ಮಮ್ಮಿ ಏನು ಮಾಡಿರ್ತಾರೆ? ಅನ್ನ ಸಾರು ಹಾಕಿಟ್ಟಿರ್ತಾರೆ. ಅವಾಗ ರೆಡಿ ಮಾಡಿ ಕುಕ್ಕರ್ ಹೊಡಿಸಿ ಜೊತೆಗೆ ಅನ್ನ ಸಾರು ಮಾಡಿ ಏನು ಹಾಕಿರ್ತಾರೆ? ಪ್ಲೇಟ್ನಾಗ ಹಾಕಿಟ್ಟಿರ್ತಾರೆ. ನೀ ಊಟ ಮಾಡಿರಿ, ಇಲ್ಲಿ ಹಾಕಿಟ್ಟಿರ್ತೀನಿ ಅಂತ ಹೇಳಿರ್ತಾರೆ. ನೀವೇನು ಮಾಡ್ತೀರಿ? ಹಾಂ ಮಮ್ಮಿ ಅಂತ ಹೇಳ್ತೀರಿ. ಯಾರೋ ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಕಾಲ್ ಬಂತಂದ್ರೆ ಮಾತಾಡ್ಕೊಂಡು ಇರ್ತೀರಿ. ರೈಸ್ ಸಾಂಬಾರು ಪ್ಲೇಟ್ನೊಳಗೆ ಹಾಕಿಟ್ಟು ತನ್ನಷ್ಟಕ್ಕೆ ತಾನು ಆರ್ತೈತಿಲ್ಲ, ಅದಕ್ಕೆ ಏನಾದರೂ ನಾವು ಎನರ್ಜಿ ಕೊಡ್ಬೇಕನ್ನ? ಇಲ್ಲಲ್ಲ. ಅದೇ ರೀತಿ ಯಾವುದೋ ಒಂದು ರಿಯಾಕ್ಷನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಆಗಿ ತನ್ನಷ್ಟಕ್ಕೆ ತಾನೇ ಆಗ್ಬೇಕಂತಂದ್ರೆ ವಾಟ್ ಆರ್ ದ ಕಂಡೀಷನ್ಸ್ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ in terms of Gibbs free energy. Gibbs free energy ಅಂದ್ರೆ ಯಾವುದೇ ರಿಯಾಕ್ಷನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಆಗ್ಬೇಕಂತಂದ್ರೆ ಡೆಲ್ಟಾ ಎಚ್ ಮೈನಸ್ ಟಿ ಡೆಲ್ಟಾ ಎಸ್ ಅಂತ ತಗೋತೀವಿ. ಡೆಲ್ಟಾ ಎಚ್ ಫಾರ್ ಎಕ್ಸಾಥರ್ಮಿಕ್ ವಿ ಕೇಮ್ ಟು ನೋ ದಟ್ ಇಟ್ ಈಸ್ ನೆಗೆಟಿವ್, ತನ್ನಷ್ಟಕ್ಕೆ ತಾನೇ ಆಗ್ತದೆ. ಎಂಥಾಲ್ಪಿ ಚೇಂಜ್ ಏನಿರ್ತೈತಿ? ನೆಗೆಟಿವ್. ಆ್ಯಂಡ್ ಸಿಮಿಲರ್ಲಿ ಫಾರ್ ಎಂಡೋಥರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್ ಅಂದರೆ ನೀವು ಯಾವುದೋ ಒಂದು ಫೋರ್ಸೆಬಲಿ ರಿಯಾಕ್ಷನ್ ಮಾಡಕತ್ತೀರಿ, ಅದು ಫೋರ್ಸೆಬಲಿ ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರಾಸೆಸ್ ಮಾಡ್ಲಿಕ್ಕತ್ತೀರಿ. ಅಲ್ಲಿ ಏನಾಗ್ತೈತಿ? ಎನರ್ಜಿ ಫಾರ್ ಎಂಡೋಥರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್, ಸಾರಿ, ಇಟ್ ಈಸ್ delta S is positive. Delta S is positive. Positive energy is required. Negative in the sense energy is going to be released. Now let us see here for the adsorption process. These are the general Gibbs free energy we have seen here. Fine. And now we can see here for adsorption process, adsorption is exothermic. We came to know that adsorption is exothermic. Now for the adsorption is to be exothermic, delta H value will be negative. Whenever on the surface molecules are coming and they are adhering, while adhering to the surface energy is released and it is negative in nature. See here for adsorption to be exothermic, delta S value we have seen here. Delta S value, that is randomness, also be negative. Randomness, they were randomly, they are wandering here and there. Molecules, gas molecules, you have applied certain pressure, while during applied pressure they will coming and adhering onto the surface, then also energy is going to be released. Now so these are the two conditions we have understood clearly. Adsorption process spontaneous ಆಗ್ಬೇಕಂತಂದ್ರೆ delta H value negative ಇರಬೇಕು, delta S value ಕೂಡ negative ಇರಬೇಕು. Next coming to this one, delta G ಈಗ delta H ಈ ರೀತಿ negative, this is also negative, I have written here positive. For the spontaneous reaction, if the delta G value is also negative, then only reaction is considered as spontaneous. Listen to me very carefully. And here this expression I have written for spontaneous reaction of the adsorption. What I have taken here? Delta S value, randomness. Delta H, enthalpy I have taken. This is entropy, enthalpy. Entropy value, negative, negative, negative. I have written here positive. So this will be the expression, Gibbs free energy expression for the adsorption process in which I tell you delta G must be negative, delta S also be negative, and delta H must also be negative. When all these three factors are negative, then we can say that adsorption can take place spontaneously without any supplying external energy. So in order to the adsorption process be spontaneous, all the three values must be negative in nature. I hope this is understood to you. Clearly understood this one, we'll move to the next part. Take down, write down properly, we'll move to the next. Now let us understand regarding the types of adsorption process. There are mainly two types of adsorption process we supposed to learn. So first one is physisorption and second one is chemisorption. Definitely on this one 2 marks question 100% you can make a write that note that 3 stars you can put. 100% differences between the physisorption and chemisorption. Definitely question is going to be asked for your examination. Okay, so physisorption, as name itself suggests, it is considered as physical adsorption. Chemisorption, it is considered as chemical adsorption. Now I will give you one example. Here, adsorption of ammonia gas on charcoal is considered as physisorption. Physical adsorption generally requires very low temperature. And remember, this physical adsorption takes place with the molecules having very weak van der Waals force of attractions. I'll write here. This process takes place. This process takes place between molecules having weak van der Waals force of attractions. Weak van der Waals force of attractions. Due to weak van der Waals force of attractions, we can provide only little energy to get adsorbed. The molecules which are wandering here and there in the surrounding, they must be adsorbed. For that process, with a very low energy, low temperature if you provide also, adsorption process is going to take place. Remember. Then we have chemisorption. Chemisorption is a process involving, that adsorption process is involving in a molecules having strong force of attraction. See here, this process takes place between the molecules having strong force of attraction. Strong force of attraction between them. Due to strong force of attraction between the molecules, we need certain amount of activation energy for them to get adsorbed. I repeat my words. Physical adsorption, chemical adsorption, there are a lot of differences. For physical adsorption with a very low temperature or with a very minimum activated energy, adsorption process takes place. But for chemical adsorption to be take place, we are supposed to provide higher amount of activation energy. Fine. And this chemical adsorption generally occurs between the molecules having strong force of attraction between them. When the force of attraction is very strong, we are supposed to provide little more energy. Activation energy is needed for them to convert to the adsorption process. At a high temperature, adsorption, that is chemisorption, is feasible. At the most of the highest temperature, definitely bonds are going to break. That is again the other issue. But in comparison to the physical adsorption, we need certain extra amount of activation energy, certain extra amount of temperature is required for chemisorption to take place. I have given here one example. Adsorption of hydrogen gas on platinum is the example for chemisorption. I tell you one more thing here, that whenever you consider, like for example, hydrogen gas. So hydrogen gas is undergoing physical adsorption. Hydrogen gas is adsorbing on the surface of nickel. Let us consider this is the nickel surface. Physical adsorption, physisorption, PHYSISORPTION. So remember this example I am explaining here. Hydrogen gas is adhering to the nickel surface. Nickel is an adsorbent which is providing the surface. Adsorbent is H2 hydrogen gas. It is coming and adsorbing on the nickel surface in physics option with low temperature. I repeat my words, with low temperature. The low temperature is going to be provided for physics option. The process which is carried out at low temperature in physics option can be converted into chemis option process by increasing the temperature. Right? So see here, I give you with a proper explanation. Just these are the definitions I have given. There are lot many differences we have to maintain here. Before to that, let us understand this concept and let us further write differences between the physics option and chemis option. This is just definition part along with the example I have given. Differences we'll see later. Before to that, let us explain this one. See here, as I told you, this is considered as hydrogen gas. Hydrogen gas is coming and adhering onto the nickel surface, and this process we can call it as physisorption. We can call it as what? We can call it as physisorption. And physisorption, as I told you, takes place at low temperature. And the same reaction which is taking place in the low temperature, we call it as physisorption, can be converted into chemisorption under high temperature. See here. When you increase the temperature, hydrogen gas which is initially coming will be divided into hydrogen and they will get adhere onto the nickel surface. They will get adhere onto the nickel surface like this. So what happens? Increased temperature has made hydrogen gas to break into HH, and hydrogen atoms come and they start adhering onto the surface. They will come and they start adhering onto the surface. And physisorption process which is taking place at low temperature is being converted into chemisorption process under high temperature. See here. So this process we can call it as chemisorption. Chemisorption with high temperature. With high temperature. High temperature in the sense comparatively high temperature than that of the physical adsorption. So I could write here along with these examples the process of physisorption taking place at low temperature, can be converted into chemisorption under high temperature. So this is the important conversion we need to remember. So do copy this one. We'll see what are the main differences we can quote for physisorption and chemisorption. Please do copy this. Welcome back, dear students. As I told you, this is most important. Definitely 100% question can be asked on this one. That is the difference between the chemisorption and physisorption. We'll understand the differences between the physisorption and chemisorption one by one in detail. Along with that, we'll see what are the main characteristics for chemisorption and physisorption processes. See here. Physisorption I have written. Physisorption reactions or physisorption adsorption is very not specific. It is not specific. And if you consider chemisorption process, it is very specific. I give you one example. Here, let me have the surface. I will be having more than two types of molecules are existing. This is one type of molecule. This is other type of molecule. Okay, this is one type. Here I have molecule. This is also. In case of physisorption, this is surface. Adsorption surface will provide surface for all these molecules to come and adhere. See here, this will also come, this will also come, again this will also come, this comes, this will also come, like this. It means that Whenever you consider physics option, it will allow all the types of molecules get added on that one. It is not at all specific, it is not choosy. ಕೆಲವೊಂದಿಷ್ಟು ಜನ ಇರ್ತಾರ, ಒಂದಿಷ್ಟು ಪರ್ಟಿಕ್ಯುಲರ್ ಫ್ರೆಂಡ್ಸ್ ಇರ್ತಾರ ಅವ್ರಿಗೆ. ಇನ್ನು ಕೆಲವೊಂದಿಷ್ಟು ಜನ ಏನಿರ್ತಾರ ಅವರು ಭಾಳ ಮಂದಿ ಫ್ರೆಂಡ್ಸ್ ಇರ್ತಾರೆ. ಎಲ್ಲರಿಗೂ ಹಾಯ್ ಹಲೋ ಏನಿ ಬಂದಿ ಹಾಯ್ 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 ಹವರ್ ಯು ಎಲ್ಲರನ್ನೂ ಮಾತಾಡಿಸ್ತಿರ್ತಾರೆ. ಆ್ಯಂಡ್ ಅವರು ಭಾಳ ಜನ ಫ್ರೆಂಡ್ಸು ಇರ್ತಾರೆ, ಬರ್ತಿರ್ತಾರೆ ಹೋಗ್ತಿರ್ತಾರೆ ಹಾಯ್ ಹಲೋ ಇಷ್ಟ. ಬಟ್ ಕೆಲವೊಬ್ರಿಗೆ ಏನಿರ್ತಾರೆ ಚೂಸಿ, ವೆರಿ ಚೂಸಿ, 2 ರಿಂದ 3 ಮಂದಿ ಮ್ಯಾಕ್ಸಿಮಮ್ 4 ಜನ ಇಷ್ಟೇ ಜನ ಫ್ರೆಂಡ್ಸ್ ಇರ್ತಾರೆ. ಅವ್ರು ಜಾಸ್ತಿ ಜನ ಜೊತೆ ಮಾತಾಡ್ತಿರಂಗಿಲ್ಲ. ತಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಏನಿರುತ್ತಲ್ಲ ಅವ್ರ ಜೊತೆ ಅಷ್ಟೇ ಹಾಯ್ ಹಲೋ ಎಲ್ಲ ಎವ್ರಿಥಿಂಗ್. ಇನ್ ಡೆಪ್ತ್ ದೇ ವಿಲ್ ಬಿ ಆ್ಯಂಡ್ ದೇ ಹ್ಯಾವ್ ಬಾಂಡೆಡ್ ದೇರ್ ಫ್ರೆಂಡ್ಶಿಪ್ ಇನ್ ಸಚ್ ಎ ಮ್ಯಾನರ್ ದಟ್ ಇಟ್ ಈಸ್ ಆಫ್ ಸೋ ವೆರಿ ಲಾಂಗ್ ಟೈಮ್. ಬಾಂಡಿಂಗ್ ಆಗುವಾಗೂ ವೆರಿ ಸ್ಪೆಸಿಫಿಕ್. ಅವ್ರ ನೇಚರ್ ಏನು, ಹೆಂಗದಾರ, ವೆದರ್ ದೇ ಆರ್ ಚೀಟಿಂಗ್ ಆರ್ ದೇ ಆರ್ ಗುಡ್, ದೇ ಆರ್ ಹೆಲ್ಪ್ಫುಲ್, ದೇ ಆರ್ ಕೈಂಡ್, ದೇ ಆಲ್ ದೋಸ್ ಪ್ರಾಪರ್ಟೀಸ್ ದೇ ವಿಲ್ ಬಿ ಸೀಯಿಂಗ್. ಫ್ರೆಂಡ್ಶಿಪ್ ಮಾಡ್ಕೊಳ್ಳುವಾಗ ಎಲ್ಲ ರೀತಿಲಿಂದ ಪ್ರಾಪರ್ಟಿ, ಅವ್ರ ಬ್ಯಾಕ್ಗ್ರೌಂಡ್, ಅವ್ರದ್ದು ಬೆಳೆದು ಬಂದಂಥ ಸಂಸ್ಕೃತಿ ಹೆಂಗೈತಿ ಎಲ್ಲನೂ ನೋಡಿಕೊಂಡು ಫ್ರೆಂಡ್ಶಿಪ್ ಮಾಡ್ಕೊಂಡಿರ್ತಾರೆ. ಆಮೇಲೆ ಆ ರೀತಿ ಫ್ರೆಂಡ್ಶಿಪ್ ಆದಂಥ ಫ್ರೆಂಡ್ಶಿಪ್ ಯಾವತ್ತೂ ಬ್ರೇಕ್ ಆಗಂಗಿಲ್ಲ. ಸಣ್ಣ ಪುಟ್ಟ ಜಗಳ ಬರ್ತಿರ್ತಾವೆ ಹೋಗ್ತಿರ್ತಾವೆ, ಓಕೆ. ಬಟ್ ಸ್ಟಿಲ್ ಇಷ್ಟು ಸ್ಟ್ರಾಂಗ್ ಇರ್ತಾರಂತಂದ್ರೆ ಯಾರು ಬಂದು ಏನು ಚಾಡ ಹೇಳಿದ್ರು ಅವ್ರ ಫ್ರೆಂಡ್ಶಿಪ್ ಬ್ರೇಕ್ ಆಗಂಗಿಲ್ಲ. ದಟ್ ಈಸ್ ಕೈಂಡ್ ಆಫ್ ಸ್ಪೆಸಿಫಿಕ್. That specificity of adsorption process is seen in chemisorption. But here as I told you, ಯಾರ್ಯಾರು ಬರ್ತಾರ ಎಲ್ಲರಿಗೂ ಹಾಯ್ ಬಾಯ್ ಹೇಳೋದು ಅಂದ್ರೆ ನಾಟ್ ಸ್ಪೆಸಿಫಿಕ್. ಇನ್ ಕೇಸ್ ಆಫ್ physics option, adsorption is not at all very specific. But in case of chemisorption, adsorption is very specific. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಯಾವುದೋ ಒಂದು ಸರ್ಫೇಸ್ ತೊಗೊಂಡಿವಂದ್ರೆ ಆ ಸರ್ಫೇಸಿಗೆ ಇಂಥದ್ದೇ ಮಾಲಿಕ್ಯೂಲ್ ಬಂದ ಅಡೇರ್ ಹಾಕಬೇಕು. ದಟ್ ಈಸ್ ಕೈಂಡ್ ಆಫ್ specificity is seen in chemisorption. Next point you can see here, let me rub this one. Okay, next point, low critical temperature of gases. Low critical temperature in the sense already ಅವು ಏನದಾವಲ್ಲ weak van der Waals force of attraction ಒಳಗೆ ಎಕ್ಸಿಸ್ಟ್ ಅದು. ಸ್ಟ್ರಾಂಗ್ ಬಾಂಡಿಂಗ್ ಇರಂಗಿಲ್ಲ, ವೀಕ್ ಇಷ್ಟು ದೂರದ್ದು ಇರ್ತಾವೆ. ಅದಕ್ಕೆ ಸ್ವಲ್ಪ ಎನರ್ಜಿ ಕೊಟ್ಟರೆ ಸಾಕು ಅವು ಬಂದು ಏನಾಗ್ತಾವೆ ಅಡೇರ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಾವೆ. ಗೊತ್ತಾಯ್ತು? ಎಷ್ಟು ಜಲ್ದಿ ಅಡೇರ್ ಆಗ್ತಾವೋ ಅಷ್ಟೇ ಜಲ್ದಿ ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ರಿಮೂವ್ಡ್ ಫ್ರಮ್ ದ ಸರ್ಫೇಸ್. ಡಿಸಾರ್ಪ್ಷನ್ ಆಗ್ತೈತಿ. ಎಷ್ಟು ಬೇಗ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಆಗ್ತೈತಿ ಅಷ್ಟೇ ಬೇಗ ಡಿಸಾರ್ಪ್ಷನ್ ಆಗ್ತೈತಿ. ಎದ್ರೊಳಗೆ ಫಿಸಿಕ್ಸ್ ಆಪ್ಷನ್ ಒಳಗೆ. chemisorption ಒಳಗೆ in order to make adsorption process to be in order to make the adsorption process we must have to give highest energy compared to physics option. ಟೆಂಪ್ರೇಚರ್ ಏನೈತಲ್ಲ ಲಿಟಲ್ ಜಾಸ್ತಿ ಕೊಡಬೇಕಾಗ್ತೈತಿ. ಸ್ಟ್ರಾಂಗ್ ಬಾಂಡಿಂಗ್ ಇರೋದ್ರಿಂದ in order to give we need to make higher energy we should provide to adsorption takes place in chemisorption. Higher energy in the sense higher activation energy. You might have seen. What do you mean by activation energy? I'll show you. This is called as activation energy. Diagram I have shown here. This is called as activation energy. You might have studied regarding the activation energy. Activation energy is minimum amount of energy required to convert from reactants to products. Activation energy ille bonding strong irodrinda ಜಾಸ್ತಿ ಬೇಕು. High activation energy and high critical temperature of gases is required. Now see here. Here very negligible amount of activation energy is required and this process can be carried out at low critical temperature. But here we need high critical temperature. Appreciable amount of activation energy needed. Appreciable amount of that is negligible amount of activation energy is enough. Here in case of this reaction as I told you ಎಷ್ಟು ಬೇಗ adsorption ಆಗ್ತೈತಿ ಅಷ್ಟೇ ಬೇಗ ಡಿಸಾರ್ಪ್ಷನ್ ಆಗ್ತೈತಿ. ಅಂದ್ರೆ ಇದನ್ನ ಏನು ಮಾಡ್ಬೋದು ನಾವು ರಿವರ್ಸಿಬಲ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ಬೋದು. ಬಟ್ ಹಿಯರ್ ಸಿ ಇಟ್ ಈಸ್ ವೆರಿ ಸ್ಪೆಸಿಫಿಕ್. ಒನ್ಸ್ ದ adsorption takes place it is highly tough to break the bonds and make it dissolved. ಅಂದ್ರೆ ಇದ್ರದ್ದು ಎಕ್ಸ್ಟೆನ್ಷನ್ ಆಫ್ adsorption ಭಾಳ ಟೈಮ್ವರೆಗೂ ಇರ್ತದೆ. ಬಟ್ ಹಿಯರ್ as soon as adsorption takes place it can be dissolved. Desorption takes place and it is considered as reversible. It is irreversible. Next point you can see enthalpy of adsorption is less. Nodri ille 20 to 40 kilojoules per mole ಇಷ್ಟು ಎನರ್ಜಿ ಪ್ರೊವೈಡ್ ಮಾಡೋದ್ರಿಂದ adsorption ಆಗಿಬಿಡ್ತೈತಿ. ಬಟ್ ದಿಸ್ ರೇಂಜ್ ಈಸ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ 10 times more than that. ಇಲ್ಲೇನು ತೊಗೊಂಡಿರಿ 20 ಇದ್ದದ್ದು ಎಕ್ಸಾಕ್ಟ್ಲಿ ನೋಡ್ರಿ 80 to 240 kilojoules per mole energy is required to adsorption to carry out chemisorption. Here multi-layer, as I told you, one layer, first layer bantu, second layer, third layer, fourth. Hi, hello, bye bye, everything is fine, okay, but okay is physics option. Andre one layer bandru, okay, yeah, ಬರ್ರಿ. Second layer, ಬರ್ರಿ. Third layer, okay, come, like that. But chemist option makes only one layer. Unilayer adsorption takes place in chemist option. This is multi-layer molecular formation. It is monolayer molecular formation of adsorption takes place. These are differences along with their characteristics I have explained you. Definitely you can expect question from this one for your examination. So please do copy this. We'll move to the next. Welcome back, dear students. We have started with a new session here, that is adsorption isotherm. First and foremost, let us understand what you mean by isotherm. Iso in the sense same, that word is referred as same, iso. Therm in the sense definitely it is somewhere related to the temperature or thermal energy and so on. Whenever we consider same temperature or constant temperature, how does adsorption is going to vary? That is going to be studied under adsorption isotherms. I have given here a definition. A graph drawn between the extent of adsorption and pressure of P of a gas at constant temperature is called as adsorption isotherm. It is not so much of a complex what the word is, sentence is written there. It is very simple. How exactly adsorption process is going to vary if you keep the temperature constant and if you increase the pressure. Pressure anna ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಹೋದಂಗ ಟೆಂಪರೇಚರ್ ಅನ್ನ ಕಾನ್ಸ್ಟೆಂಟ್ ಇಟ್ಟರೆ adsorption process ಹೆಂಗೆ ವೇರಿ ಆಗ್ತದೆ, ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೋ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೋ, ಅದನ್ನ ಯಾವುದರಿಂದ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋತೀವಿ, ಅದನ್ನ adsorption isotherm process ಲಿಂದ ಅರ್ಥ ಮಾಡ್ಕೋತೀವಿ. There are two types of adsorption isotherms are there, that is Freundlich adsorption isotherm and Langmuir's adsorption isotherm. Freundlich adsorption isotherm you are going to learn in detail in your syllabus, and Langmuir's isotherm you will be studying in your higher classes when you go to BSc, MSc and so on. There you will be learning. Now coming back here, let us start with Freundlich adsorption isotherm. Isotherm ಅಂದ್ರೆ ಏನೆಲ್ಲರಿಗೂ ಗೊತ್ತಾಯ್ತಲ್ಲ, ಟೆಂಪರೇಚರ್ ಅನ್ನ ಕಾನ್ಸ್ಟೆಂಟ್ ಇಟ್ಟಾಗ how does it vary, when you increase the temperature how does it vary? Definitely pressure at least it will be increasing only. Listen to me properly. Extent of adsorption, that is effect of pressure, how does it depend on adsorption process? So if you just increase the pressure, see what happens. I have drawn here a graph. This graph indicates x by m. I have drawn a graph versus x by m versus pressure. X by m andre endile amount of gas adsorbed. Gas anna ನಾವು ಏನು ಮಾಡಾಕತ್ತೀವಿ, ಸರ್ಫೇಸ್ ಮೇಲೆ ಅಡೇರ್ ಆಗೋ ಥರ ಮಾಡಾತೀವಿ. ಎಮ್ ಅಂದ್ರೇನ ಮಾಸ್ ಆಫ್ adsorbate. ಮಾಸ್ ಅಂದ್ರೆ adsorbate ಎಷ್ಟು ಮಾಸ್ ಐತೆ ಅಂದರೆ ಅದರದ್ದು ಸರ್ಫೇಸ್ ಏರಿಯಾ ಎಷ್ಟೈತಿ, ಎಷ್ಟು ಅಗಲ ಇದೆ, ಇಷ್ಟೈತೋ. ಡೆಫಿನೆಟ್ಲಿ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಜಾಸ್ತಿ ಇದ್ದಂಗೆ adsorption ಜಾಸ್ತಿ ಆಗ್ತೈತಿ, ಸರ್ಫೇಸ್ ಏರಿಯಾ ಕಡಿಮೆ ಇದ್ರೆ adsorption ಕಡಿಮೆ ಆಗ್ತೈತಿ. ನಾವು adsorption surface area or the adsorbate if you consider, that is mass of adsorbent, and x is kind of mass of adsorbate. Here adsorbate we are considering gaseous molecules. If pressure is increasing here, okay, if pressure is increasing, x by m, can you see initially it is increasing, initially starting point ಒಳಗ ಇದನ್ನ ನೀವು 0 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಸ್ಟಾರ್ಟಿಂಗ್ ಏನಾಗತೈತಿ, ಪ್ರೆಷರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದಂಗೆ ಎಲ್ಲ ಕಡೆ ಏನಾಗ್ಲಿಕ್ಕತ್ತದ, adsorption process it is increasing. Here we can see it is increasing, initially increasing it is, later on it is giving a straight line or like plateau. Straight line ಬರ್ಲಿಕ್ಕತ್ತದ, plateau ತರ ಐತಿ ಅಂದ್ರೆ ಏನಾಗ್ಲಿಕ್ಕತ್ತದ, adsorption ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ಉಳಿಲಿಕ್ಕತ್ತದ, ಜಾಸ್ತಿ ಆಗ್ಲಿಕ್ಕತ್ತಿಲ್ಲ. ಪ್ರೆಷರ್ನ ಜಾಸ್ತಿ ಮಾಡಿದಾಗ ಸರ್ಟನ್ ಎಕ್ಸ್ಟೆಂಟ್ ವರೆಗೂ adsorption ಏನಾಗ್ತೈತಿ, ಜಾಸ್ತಿ ಆಗ್ತೈತಿ. ಒಂದು ಫಿಕ್ಸ್ ಟೈಮಿಗೆ adsorption ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಫ್ ಪ್ರೆಷರ್ ಆಗ್ತೈತಿ. ನೋಡ್ರಿ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಹೇಳ್ತೀನಿ ನಿಮಗೆ. Say for example, this is a duster. This is a duster. Adsorption is taking place. One molecule banta 2 3 4 5 6 ಎಷ್ಟು ಸರ್ಫೇಸ್ ಏರಿಯಾ ಐತಿ ಅಲ್ಲೆಲ್ಲ ಕಡೆ ಏನು ಬರಕತ್ತೈತಿ, you are seeing here these molecules are adhering. ಹೌದಾ, ಇಲ್ಲಿ ನೋಡ್ರಿ ನಾ ಹೆಂಗೆ ಡಾಟ್ 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 ಮಾಡ್ತಾ ಹೋದಂಗೆ ಎಲ್ಲ ಏನಾಗತ್ತದ ಪ್ಲೇಸ್ ಪೂರ್ತಿ ಕವರ್ ಆಗ್ಲಿಕ್ಕತ್ತದ, ಕಂಪ್ಲೀಟ್ ಆಗ್ಲಿಕ್ಕತ್ತದ. ಹೌದಾ, ಪ್ಲೇಸ್ ಏನಾಗ್ಲಿಕ್ಕತ್ತೈತಿ, ತುಂಬಲಿಕ್ಕತ್ತೈತಿ ಎಡ್ಸಾರ್ಪ್ಷನ್ನಿಂದ. ಪ್ರೆಷರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡೀನಿ, ಎಡ್ಸಾರ್ಪ್ಷನ್ ಆಗತ್ತೈತಿ, ಕಂಪ್ಲೀಟ್ ತುಂಬಲಿಕ್ಕತ್ತದ. ಈಗ ನೋಡ್ರಿ ಹೆಂಗೆ ತುಂಬ್ತಾ ಹೊಂಟೈತಿ. ನೆಕ್ಸ್ಟ್ ನೋಡ್ರಿ ಇಲ್ಲಿ ಎಲ್ಲಾದ್ರೂ ಜಾಗ ಉಳಿತದ, ಎಲ್ಲ ಕಡೆ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಫಿಲ್ಅಪ್ ಆಗ್ಲಿಕ್ಕತ್ತದ. ಇದು adsorption process at a high pressure. It is taking place now. What I am doing, I am increasing the pressure and doing the adsorption. ಇಷ್ಟೊಂದು ಡಾಟ್ಸ್ ಆದಮೇಲೆ ಕಂಪ್ಲೀಟ್ ಇದು ಫಿಲ್ಅಪ್ ಆಗ್ತೈತಿ, ಪೂರ್ತಿ ಇದು ಬ್ಲ್ಯಾಕ್ ಈ ಥರ ಕಾಣಿಸ್ತೈತಿ. ಇಲ್ಲಿ ಸರ್ಫೇಸ್ ಏನೈತಲ್ಲ ಪೂರ್ತಿ ಫಿಲ್ಅಪ್ ಆದ ತಕ್ಷಣ ಈ ಥರ ಕಾಣಿಸ್ತೈತಿ. ಹಿಂಗಾದಾಗ ಏನಾಗ್ತೈತಿ, ನೀವು ಇನ್ನೂ ಎಡ್ಸಾರ್ಪ್ಷನ್ ಮಾಡಕತ್ತೀರಿ, ಇನ್ನೂ ಇಲ್ಲೆಲ್ಲ ಡಾಟ್ಸ್ ಮಾಡಕತ್ತೀರಿ ಅಂದ್ರೆ ಏನಾಗ್ತೈತಿ, ಎಡ್ಸಾರ್ಪ್ಷನ್ ಆಗಂಗಿಲ್ಲ. ಇಲ್ಲಿಂದ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಹೊರಗೆ ಬರ್ತಾವೆ, ಡಿಸಾರ್ಪ್ಷನ್ ಆಗ್ತೈತಿ. ಗೊತ್ತಾಗ್ತೈತದ ಹೇಳ್ತಾರದು. ಸೊ at certain extent adsorption will be increased due to increase in pressure. ಪೂರ್ತಿ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಕಂಪ್ಲೀಟ್ ಆದಮೇಲೆ ಮಾಲಿಕ್ಯೂಲ್ಸಿಗೆ ಎಲ್ಲಿ ಜಾಗನ ಉಳಿಯಂಗಿಲ್ಲ ಇಲ್ಲಿ ಬಂದು ಅಟ್ಯಾಚ್ ಆಗಲಿಕ್ಕೆ. ಆವಾಗ ನೀವು ಎಷ್ಟು ಪ್ರೆಷರನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದರೂ ಕೂಡ ಎಡ್ಸಾರ್ಪ್ಷನ್ ಪ್ರೊಸೆಸ್ಸು ಆಗಂಗಿಲ್ಲ. ಎಡ್ಸಾರ್ಪ್ಷನ್ ಪ್ರೊಸೆಸ್ ಬಿಕಮ್ಸ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಫ್ ಪ್ರೆಷರ್. ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಫ್ ಪ್ರೆಷರ್ ಇನ್ ದ ಸೆನ್ಸ್ adsorption will become p raised to 0. 0 ವ್ಯಾಲ್ಯೂ ಬಂದ್ಬಿಡ್ತದೆ ಅಲ್ಲಿ. So here it is increasing. This is the middle range, and here we can consider x by m becomes p raised to 0. Plateau, constant it will become. That is, adsorption become independent of pressure. Independent of pressure p. That is pressure p raised to 0 we can consider. ಇಲ್ಲಿ ನೋಡ್ರಿ, I have drawn 3 lines here. From origin to 273, from origin to 244, and from here to 195. Can you see this 195 is smallest value for all the two? That means at low temperature adsorption process is maximum. If you are increasing the temperature, adsorption is decreasing. ಏನಾಗ್ತೈತಿ, ಈಗ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಲ್ಲಿ ಓಡಾಡ್ತಿರ್ತಾವೆ, ಸ್ವಲ್ಪ ಟೆಂಪ್ರೇಚರ್ ಕೊಡೋದ್ರಿಂದ ಏನಾಗ್ತಾವೆ, ಇಲ್ಲಿ ಬಂದು ಅಡೇರಾಗ್ತಾವೆ. ನೀವೇನಾದರೂ ಕೊಡೋ ಟೆಂಪ್ರೇಚರ್ನ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ ಏನಾಗ್ತಾವೆ, ಅಡ್ಸಾರ್ಬ್ ಆಗಿರುವಂಥ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಡಿಸಾರ್ಬ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಾವೆ. ಸ್ಲೋಲಿ ದೇ ವಿಲ್ ವೈಬ್ರೇಟ್ ಲೈಕ್ ದಿಸ್. ಸ್ಟಿಲ್ ಇಫ್ ಯು ಆರ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ದ ಟೆಂಪ್ರೇಚರ್ ದೇ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಡಾನ್ಸಿಂಗ್ ಇನ್ ದ ಸಿಸ್ಟಮ್. ಡಾನ್ಸ್ ಮಾಡೋಕೆ ಚಲೋ ಮಾಡ್ತಾವೆ ಅಲ್ಲಲ್ಲಲ್ಲಲ್ಲಲ್ಲ ಎಲ್ಲ ಕಡೆ. ನೀರು ನೋಡಿರಿ, ಬಾಯ್ಲಿಂಗ್ ವಾಟರ್ ನೀವೇನು ಮಾಡಿರ್ತೀರಿ, ಒಲಿ ಮೇಲೆ ನೀರು ತುಂಬಿಟ್ಟಿರ್ತೀರಿ, ಒಂದು ವೆಸಲ್ ಒಳಗೆ, ಒಂದು ಬಗೋಣಿ ಒಳಗೆ ನೀರು ಹಾಕಿಟ್ಟಿರ್ತೀರಿ. ಸ್ಟಾರ್ಟಿಂಗ್ ಏನಾಗ್ತೈತದ, ಸ್ಲೋ ಆಗಿ ಬಾಯ್ಲಿಂಗ್ ಸಣ್ಣ ಗುಳ್ಳಿ ಬರ್ತಾವಿಲ್ಲ, ಸಣ್ಣ ಗುಳ್ಳಿ ನೀರು ಕಾಯುವಾಗ ಸಣ್ಣ ಗುಳ್ಳಿ ಬರ್ತಿರ್ತೈತಿ. ಆಮೇಲೆ ಏನು ಮಾಡ್ತೀರಿ, ಅಷ್ಟು ಬಂದ ತಕ್ಷಣ ಆ್ಯಕ್ಚುಲಿ ನೀವು ಬಂದ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ನೀರು ಕಾದೈತಿ ಅಂತ ಅರ್ಥ. ಆದರೂ ನೀವೇನು ಮಾಡ್ತೀರಿ, ಸ್ವಲ್ಪ ಕುದಿಲಿ ನೀರು ಫುಲ್ ಅದ್ರಾಗಿದ್ದೆಲ್ಲ ಏನದಾವು ಮೈಕ್ರೋಬ್ಸ್ ಅಥವಾ ಏನೇನು ಇಂಪ್ಯೂರಿಟೀಸ್ ಎಲ್ಲ ಹೋಗಲಿ ಅಂತೇಳಿ ಏನು ಮಾಡ್ತೀರಿ, ನೀವು ಇನ್ನೂ ಕಾಯಿಸ್ತಾ ಇರೋ ಜೋರು ಟೆಂಪ್ರೇಚರ್ ಅಂದ್ರೆ ಒಲಿದ ನಾಬನ್ನು ಫಾಸ್ಟ್ ಮಾಡ್ತೀರಿ. ಅವಾಗ ನೀರು ಏನಾಗ್ತೈತಿ, ಪಳ ಕುದಿಯಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗಿ ಹೊರಗಡೆನೂ ಬೀಳ್ತೈತಿ. ಹೌದಿಲ್ಲ? ದ್ಯಾಟ್ ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತಾ ಇದ್ದೀನಿ ನಾನು ನಿಮ್ಗೆ. ಅದು ಆ್ಯಕ್ಚುಲಿ ಎಡ್ಸಾರ್ಪ್ಷನ್ ಪ್ರಾಸೆಸ್ ಅಲ್ಲ, ಬಟ್ ಟೆಂಪ್ರೇಚರನ್ನು ಜಾಸ್ತಿ ಮಾಡೋದ್ರಿಂದ ಏನಾಗ್ತೈತಿ, ಎಡ್ಸಾರ್ಬ್ ಆಗಿರೋಂಥ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ದೇ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಡಿಸಾರ್ಪ್ಷನ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತೈತಿ. ದೇ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಮೂವಿಂಗ್, ದೇ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಡ್ಯಾನ್ಸಿಂಗ್ ಇನ್ ದ ಸಿಸ್ಟಮ್, ದೇ ವಿಲ್ ಮೂವ್ ಅವೇ ಫ್ರಮ್ ದ ಸರ್ಫೇಸ್. So if you increase the temperature, adsorption decreases. The same I have mentioned here. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇನಿಷಿಯಲಿ ಇದು x by m ವ್ಯಾಲ್ಯೂ ಏನು ತೊಗೊಂಡಿದ್ದೀನಲ್ಲ, ಇಟ್ ವಿಲ್ ಬಿ ಸಮ್ಹೌ 1 ಅಂದ್ರೆ ಇನ್ಕ್ರೀಸ್ ಆಗತೈತಿ, ನಾಟ್ ಲೆಸ್ ದ್ಯಾನ್ n ವ್ಯಾಲ್ಯೂ ಏನೈತಲ್ಲ 1 ಇರ್ತೈತಿ. 1 ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, ನಾವು ಇಫ್ ಯು ಕನ್ಸಿಡರ್ x by m ರೇಂಜ್ 1 ಅಂದ್ರೆ adsorption process is increasing. ಇಲ್ಲಿ ಏನು ಬರ್ತೈತಲ್ಲ adsorption ಇನ್ ಬಿಟ್ವೀನ್, ಇಲ್ಲೇ 0 ಆಗ್ತೈತಿ, ಇಲ್ಲಿ 1 ಇರ್ತೈತಿ. ಇದು ಇನ್ ಬಿಟ್ವೀನ್ 1/2, 1/3, 1/4 like that it will be. In this case x by m will be p raised to 1/n. This is nothing but we are going to learn regarding Freundlich adsorption isotherm. ಇಲ್ಲಿ ಏನಾಗ್ತೈತಿ, x by m you can consider p raised to 1 you will be taking here. Initially adsorption is increasing, then it is becoming value p raised to 1/n. Here x by m value it is becoming 0. Constant pressure increase ಮಾಡಿದ್ರು ಕೂಡ adsorption ಆಗ್ತಾ ಇಲ್ಲ. That is pressure relationship with respect to adsorption. So according to, I told you the fraction, how does it is varying from 1/2, 1/3, 1/4 and so on, then it will become 0. Initially it is 1, it is increasing. This is we are interested, which is considered as expression for Freundlich adsorption isotherm, right? So x by m is directly proportional to p raised to 1 by n. P raised to 1 by n in the sense any fraction it is. It is not 1, it is not 0 also. But in between value we will be getting here, that is 1 by 2, 1 by 3, 1 by 4 and so on. That is nothing but fraction. X by m is directly proportional to p raised to 1 by n. That is nothing but Freundlich adsorption isotherm. We have further, we supposed to solve it. We will consider that also. And one more point I have written here. If temperature is increasing, nature of adsorption is decreasing. Graph itself is a proof that under 273 Kelvin temperature, adsorption is very less. Under 195 temperature, adsorption is highest. With a low temperature, more the adsorption, higher the temperature, lower will be the adsorption. They are inversely proportional to each other. Please do copy this. We'll put a log for this expression and we'll see how to solve that one. Write it down.